Question 3, part A. In the space below, draw a circle of radius 5 centimetres. Use the cross, that little point here, as the centre of your circle. So you're going to need a compass now to draw your circle. So if you don't have one, the invigilator will give you one. So just pop your pencil in, hold the compass straight up, pointing down, pop your pencil in until it touches the bottom, until it touches your paper. So that means that wherever you draw your circle, you know the lead of your pencil is going to touch the paper. Just tighten it up nicely then. So when I draw a circle, here's a circle, the diameter goes through the centre of the circle all the way from one end to the other. Doesn't matter where that diameter is. As you can see here, there's another blue line going straight across. Doesn't matter where it is. It's just going through the centre all the way across. Now the radius in red is halfway, going from the centre to the edge of your circle. So the radius is exactly half of the diameter. Or the diameter is exactly double or twice the radius. So if you notice, if I put my compass, the centre of my circle at the point, then when I draw a circle with a compass, the distance between the point of the compass and the pencil and the edge of the circle, the circumference of the circle, is actually the radius. So the measurement I need from the point of my compass to my pencil needs to be 5 centimetres. So I'm going to measure that using my ruler. So if you rest your hand on the ruler here so it doesn't move, put the point of your compass right at 0 and move your pencil until it's at 5. That there is a radius of 5 centimetres. So now I need to make sure that I don't touch this, because if I touch it and actually move it, I'm adjusting the distance between here and here. So make sure now you're only touching the top of your compass. So if you hold your compass, so the point of your compass is right in the centre of that cross. Now hold it so your fingers are going in this direction. So your pencil is horizontal to your body and your fingers look like this. You can then just turn the compass in your fingers without having to move your body and your arm and your wrist in a silly way. So that means you'll have the motion to go most of the way round your circle just by moving your fingers. So again, I'm putting pressure on this point, and now I'm just swooping the pencil across by using my fingers. Back and forth until I end up getting a whole circle. Again, you'll notice that I haven't moved my wrist or my arm that much. I'm just using my fingers, moving them like this. If you need to move your arm slightly across, then you can to finish the end of your circle. So now that's done. If you do move your compass at any point, then you can just move your compass over the point and it will then fall into the hole you've put in the paper, and your pencil will go exactly on the line that you were on. If you do adjust your pencil at any time, just take your ruler again and measure the length at 5 centimetres, and then you should be exactly on your mark. So now I've drawn the circle. I'm just going to make sure that I've done it accurately. So I'm going to measure from the centre of that point to the edge of my circle, and that is exactly 5 centimetres. So the examiner will give you a mark if you are plus or minus 2 millimetres. So that means if you're 2 millimetres bigger or 2 millimetres smaller, you'll still get the mark. So if your radius is 4.8, 4.95, 5.1 or 5.2 centimetres, then you will get 1 mark. Now, part 2 says, what is the length of the diameter of the circle you have drawn? So we said earlier that the diameter was all the way across, which is basically double the radius. So you can actually measure it if you wish, but knowing the qualities of circles, then we know that the diameter is exactly double the radius. So from here to here will be, and it is, 10 centimetres. And that will give you 1 mark. Part B. What is the special name given to a triangle with 3 equal sides? Circle the correct answer. So I've made some notes here about the different types of triangles you can have. You can have an equilateral triangle, and the clue is in the name there, equilateral triangle. That means that all 3 sides are equal. And that's represented by those 3 lines here. That means that the 3 lines are the same, and therefore the 3 angles will be the same. And in an equilateral triangle, it doesn't matter whatever size the triangle is, all the angles will be 60 degrees. Then we have an isosceles triangle. So that's represented by these 2 lines here. And they say that those 2 lines are the same, meaning that the angles below them, they will be the same as well. We have a scalene triangle, so we don't have any lines here. So that says that no sides are the same, and therefore no angles are the same. The last one then is a right-angled triangle. So that's a triangle that has a right angle in it. And you'll notice that by this little square, and that means that that angle is 90 degrees. So it's asking to give the name of a triangle with 3 equal sides. So that's this one here, an equilateral triangle. If you didn't know any of these, then you could have had a little guess by looking at the vocabulary. So equilateral sounds a bit like equal. So we have all these types of triangles, and then we have something different here called a tetrahedron. Now a tetrahedron is basically a triangular pyramid. So it's a triangle that's been stretched up into a 3D object to a point. So if I was to draw that, this would be the point where my triangle would be stretched out to a 3D object. So it means it has a triangle face on the bottom, a triangle face on the side, and this side. So that has 4 triangular faces.